Good morning, all. Myself, Dr. Bhaskar Karangi. I'm working as an assistant professor in KLE College of Pharmacy, Belgavi, from the Department of Pharmaceutics, which is affiliated to KLE Academy of Higher Education and Research, Belgavi. Today, I'm going to present a seminar on the topic of the solubility of the drugs. This topic, which is related with the third semester of B Pharmacy syllabus. So the content of my today's seminar presentation, first one is the introduction of the solubility of the drugs, then the importance of the solubility in the pharmacy field, then the solubilization concept involved in the solubility, and lastly, the types of the solutions. Before beginning with this introduction of the solubility is one of the important physicochemical parameters of any drugs whenever you are going for the further research studies. So we have to prepare any type of the drug solutions. We have to understand what exactly the solubility term. The solubility which is defined, the particular homogeneous mixture in which one substance is said to be dissolved in other. It is the property of any type of the solid, liquid, or gaseous chemical substances that is called as the solids to be dissolved in the solid, liquid, or gaseous solvents to form a clear homogeneous solutions of the solid in the given solvent. It means the solution which is to be formed by the interaction of the solute and the solvents to form a clear homogeneous solution. The solubility of the substance that is fundamentally depending upon what type of the solvents and the solids have been involved in the solute process, as well as on the temperature and the pressure factors. There are so many factors which can affect the solubility terms. The extent of the solubility of the substance in a specific solvent that can be measured as a particular depending upon the saturated concentration. So depending upon the concentration of the solids present in the solution, that can be defined as the dilute solution or the concentrated solution. If the concentration of the solids get beyond that level, that will form the saturated solution. So to make that particular solution equilibrium, the formation of the solids in the saturated solutions, we are determining the particular concentration, where adding the more solute that does not increase the concentration of the solution upon further increasing the concentration. So while defining the solubility, we define the solubility terms in two ways, such as in quantitative way. So the solubility which can be defined in quantitative way, the maximum amount of the solids which can be dissolved into the given solvents to form a solution. In terms of the concentration of the solids in a saturated solution at a given temperature, at a specified temperature, that will forming the solution. So that is known as the solubility. But when you're defining the solubility in qualitative way, that defines it is the spontaneous interaction between the two or more substances that are involved in the formation of the solutions, and that is the formation of the homogeneous clear molecular type of the dispersion to form this solution that is known as the solubility. This solubility that can be given in terms of the different terminologies. So the solubility of the drug may be expressed in a number of ways. For example, the United States of Pharmacopoeia, which describe the solubility of drugs as the parts of the solvent which are required for one part of the solids. So similarly, the different number of the parts of the solids which are required to prepare the solids as per the requirement of the parts of the solvents. In that way, the USP defines the solubility of the drugs. Now coming towards why this solubility is important, the importance of the solubility. Before beginning of any type of the studies, research studies for any of these different preparation of the solutions, whatever, we have seen so many students are dealing in the practical aspects of the preparation of the solutions, mixtures, elixirs. Apart from that, any other further drug solutions while preparing for the further stock solution. So at that time, the solubility plays important role. Until unless we doesn't know the information about the solubility of the drugs, we cannot proceed for further research study. So it is important the physicochemical property of the drug, which is playing important in the research field. It is an important parameter to achieve the desired concentration in the systemic circulations. So why it is important? Because once the solubility of the drug is increased, by which the absorption of the drug will increase, the the absorption is increased. So due to the maximum amount of drug is available in the systemic circulation. That is depending upon the solubility of the drug in the given solution. The solubility behavior of the drug is one of the important aspects in the pre-formulation testing for poorly soluble drugs. So as I mentioned, so while going for any further research studies, we have to go for the previous pre-formulation testing of any of the drugs. So whenever in the research studies, the presence of the poorly soluble drugs, the pre-formulation testing involving the solubility playing important roles. So for the drug, whether drug is soluble in the water or not, whether drug is soluble in any other organic solvent, that you have to determine, and we have to proceed for further research studies. The selection of the best solvents for a drug or a mixture of drugs, that is the next step when you come to know the drug is soluble in the given solvent or not. And from that, the overcoming problems which are arising during the preparation of the pharmaceutical solutions. So we have seen there are so many pharmaceutical solutions which are preparing in the laboratories. As I mentioned, the mixtures, the solutions, elixirs, suspensions, emulsion, etc., where the solute plays important roles, where there is the interaction of the solute and solvents takes place to form the solution. So there are so many problems arising during the preparation of the pharmaceutical solutions. At that time, the solubility plays important role. The drugs with low aqueous solubility often presents the problem related with the formulation and the viability. Yes, as the particular drugs which having the less solubility in the water, or they're having the less amount of the drug dissolving capacity, so there is a less dissolution rate and less absorption of the drug takes place, and by which the viability of the drug can be affected. So to overcome that, we must know what is the exact solubility of the given drug. So this is the graphical representation for the solubility curve. The solubility curve which explains the relationship between the temperature and the solubility of the given drug. Whenever the graph is plotted between the temperature and the solubility of the given drug, we obtain a solubility curve. Here in graphical representation, we can see there is the three terms such as the supersaturated term, then saturated term, and unsaturated terms. So any solution that can be made saturated, unsaturated, or supersaturated by changing the temperature. So temperature have wide effect on the solubility of the given drug. As the temperature increases, the solubility also increases. But there is some exceptions. Whenever there are some exothermic type of the reaction involved, at that time the reverse effect is observed, such as increase in the temperature, solubility get decreased for exothermic reactions. So saturated solutions, which explains it is the maximum amount of solute which is in equilibrium with the given amount of the solvent and the solutes at the given temperature. But the supersaturated solution, which explains the maximum amount of solute which raise or which is above that particular concentration beyond that equilibrium layer to form the supersaturated solution. And the unsaturated solution, which explains that is the minimum amount of the solute which is unable to form the particular equilibrium solution. So that is explained by the unsaturated solubility. The next part is the solubilization. So this solubilization can be defined as the preparation of the thermodynamic stable isotropic solutions of a substance that is normally insoluble or very slightly soluble in a given solvent by the addition of the components or the different components, or you can say by addition of the any or by using any suitable methods in the preparation of the solution, that is known as the solubilization techniques. So this solubilization method which explains about the solute and solvent interaction in the preparation of the solutions. Then the solvation and dissolution process. Once the interaction between the solute and solvent takes place in the process of the solutions formation, the solvation, which is the process of attracting and associating of the molecules of a solvent with the molecules or the ions of the solutes. So that is the process of attraction between the solute molecules and the solvent molecules which takes place. So in this attraction, the different forces which can be involved between the like molecules and unlike molecules. So we'll explain in the next slides. So this is the process of solubilization which by stepwise. So in the step one, where the solvent and the solute molecules are there, so the holes opens in the solvent. So these are the solvent molecules where the formation of the cavity takes place. Then in the second step, where the molecules of the solid which breaks away from the bulk of that particular solid molecules or the solute molecules. After breaking of that solute molecules, in the third step, there is a spread of the particular solid molecules in the integrated into the holes of the solvents. So where in the solid molecules, the cavity which is formed, in that place, the molecules of the solid takes this place. In the solubility process, the mechanics, the perspective of solubilization process for organic solid in water, which involves the different steps. The first one, the breaking of the solid-solid interactive or the intermolecular bonds. So different types of the hydrogen bonds, van der Waals forces, or any other type of the chemical or induced dipole-dipole type of the interaction which are to be present, that breaking or rupturing of the solid-solid interactive bond takes place. Followed by the breaking of the solvent-solvent intermolecular bonds takes place. In the third steps, the formation of the cavity in the solvent phase, which takes for the large enough to accommodation of the solid molecules. So where these separated solid molecules that enters into the cavity form in the solvent phase. And in the fourth phase, the transfer of the solid into the cavity of the solid phase, and followed the formation of the solid-solvent intermolecular bonds. Coming towards the different types of the solutions. The solutions of the pharmaceutical importance, which includes such as the different gas molecules dissolved in the liquids, the liquid molecules dissolve into the liquids, and the solid molecules dissolve into the liquids. So depending upon what type of the solids or the molecules involved in the preparation of these solutions, these solutions have been classified such as the gases in liquids, liquids in liquids, and solids in liquids. Here, the solubility of the gases in the liquids. The best example to explain the solubility of the gases in liquids is the carbonated beverages, such as where the carbon dioxide gas which is dissolved in the water to form the different type of the carbonated beverages. So this explains whenever the pressure above that particular solution is raised or it is decreased, the solubility of the gas is decreases. If you see where the pressure on the surface of the liquid is released or decreased, by which the solubility of the dissolved gases is decreases. So there is a linear relationship between it. And as the temperature increases, the solubility of the gases also decreases. So there is the inverse relationship between the temperature and the solubility of the gases. So solubility and the liquids that are not affected, especially by using the pressure parameter. But for the solubility of the gases in the liquid that are mostly affected by using the pressure. It means as the pressure on the surface of the liquid increase, the solubility of the gases in the given liquid will also increase. As the pressure on the surface of the liquid is released or the decrease, the solubility of the given gas molecules in the liquid is decreased. So the concentration of the solid molecules at the equilibrium increases in the proportion to the pressure. So the solubility of the gas increases with the pressure. Coming towards the next point, the solubility of the liquids in the liquids. The preparation of the pharmaceutical solutions which involve the mixing of two or more liquids. When you are dealing with the particular type of the solution formulations, elixir formulations, or emulsion formulation, at that time, the solubility of the liquids in liquid playing important role. The mixture of the alcohol and water to form the hydroalcoholic solutions, the mixture of the volatile oils and the water to form aromatic waters, the mixture of the volatile oils and the alcohol to form spirits and the elixirs. At that time, the solubility of the liquids and liquids playing important roles. These liquid-liquid systems, which may be divided into two categories, such as the first one, system showing the complete miscibility, such as in between the alcohol and the water, or the water, glycerin, and the glycerin, the benzene and the carbon tetrachloride, which are forming the miscible liquids. And in the second, the system showing the partial miscibility, such as in between the phenol and water. So these two layers that are formed each the containing the sum of the other liquids in the dissolved salts. So Sometimes what happens in the miscible type of the solvents, the phenol and water mixtures, which are not miscible with each other, but at that time, some components of the solids from the phenol and water, they are dissociated in each component. So the term miscibility that refers to the mutual solubility of the components in the liquid-liquid systems. Continuation with the solubility of liquids in liquids, when the complete miscibility occurs, there are the different forces which are to be involved in the formation of the solutions, such as the adhesive forces and the cohesive forces. So the adhesive forces which involved between the different like molecules, and the cohesive force of attraction which is involved between the like molecules. So to occur the complete miscibility of the solution, such as between the water and the alcohol, at that time the adhesive forces between the different molecules is greater than the cohesive forces. Whenever the polar and semipolar solvents are involved in the formation of the solution, such as the water and the alcohol, the glycerin and alcohol, and the alcohol and acetones. So the mixture of the polar and non-semipolar solvents, at that time we are said to be they are completely miscible because they mix in all proportions. And at that time, the adhesive forces which is exerting between the unlike molecules is greater than the cohesive forces. That non-polar solvents such as the benzene and carbon tetrachlorides are also completely miscible. When you are explaining about the partial miscible type of the solutions, for example, the mixture of the different kind of the water and the hexane, at that time, the cohesive forces like molecules, it is greater than the particular the force of the adhesions. So when certain amounts of the water and the ether or the water and the phenol which are mixed together, so these two liquid layers are formed, each containing some of the other liquid in the dissolved state. The effect of the temperature on the miscibility of these two components or these two component systems is expressed by using the phase diagram. So the phase diagram of any two component systems such as the and phenol systems or the triethanol and phenol water systems. So at the end, this mixture which will having an upper critical solution temperature or lower critical solution temperature, which explains the phase behavior of these two component systems. The miscible liquids, these are the particular those liquids which are miscible in all proportions. So as I mentioned in previous slides, these ethyl alcohol and the waters which are miscible with each other, these are also known as the binary type of the liquids. So application of these of the miscible type of liquids, such as in the form of aerosol or in the solution dosage forms. And the second application, sometimes in the fractional, preparing the some type of the extract which involves the hydroalcoholic type of the extract preparation or ethanol type of the preparations. So the mixture of the ethanol and water. So at that time, the fractional distillation method development, this miscible solvents or the miscible solubility of the particular solvent take important roles. The next important point is the ideal solution, which is defined as the one in which there is no change in the proportion of the components other than the dilutions when they are mixed to form a solution. So ideal solution are the solutions when upon on the dilution of their particular solution, there is nothing change in the component of the particular solutions. So there is no shrinkage or the particular components of the given liquid takes place when liquids are to be mixed. Whenever the liquids which are to be involved in the preparation of the solutions, might be possible there is shrinkage of the takes place or expansion of the component takes place. But in ideal solution, this does not happen. The forces of attraction which are to be involved in the preparation of the solution that are remain same, such as the force of adhesions which are to be greater in the previous type of the solution. But in ideal solution, the force of cohesion and the force of adhesions are remains to be same. For example, these are the liquid mixtures, the methanol and water, which involving the common interactions such as hydrogen bonding and dipole interactions. Then and toluene mixtures, which explain the interactions such as non-polar and induced dipole interactions. Then the liquid mixtures which are involved between N-hexane and N-heptane, which involve the interactions such as the dispersion and the van der Waals process of attractions. So these ideal solutions which obeys the Raoult's law of the all concentrations and at all the temperature is known to be the ideal solution or the perfect solution. Points, what is the Raoult's law? So the Raoult's law, which explains the relationship between the vapor pressure of the given solid molecules with the mole fraction of the each components and the vapor pressure of the solid molecule. So the vapor pressure of the given liquid is directly related with the mole fraction of the given solutions, that is known as the Raoult's solution. So these solutions are the ideal solutions which obeys the Raoult's law at all concentration and at all the temperature. A solution is a particular any homogeneous phase that contains more than one components. These components that can't be physically differentiated. But when the solution involving the two components, such as the one solute and the solvent, the solvent is the component where the larger proportion or the quantity which is present in larger amount in the solution. But the solutes, that is the particular component with the smaller proportion or the quantity in the solution. The idea of the ideal solution, which is used to simplify the study of the phase equilibrium of the solutions. The solution which is considered to be ideal when its components are assumed to have similar structures or the sizes, and when it represents the complete uniformity of the molecular forces, basically the force of attraction which are to be involved, known as the ideal solution. And slide which I mentioned, the ideal solution which are obeying the Raoult's law of the solution. So these are the references of my presentation, such as the you can refer the textbook of the Physical Pharmaceutics by C.V.S. Subramaniam, Vallabh Prakashan, Physical Pharmaceutics by Alfred Martin, and third one is the Bentley textbook of the pharmaceutics. Thank you very much.